Well, welcome everyone. Thanks for joining us today to talk through PowerShell and CI/CD platforms. Today we'll be going over a practical tour of some deployment options and some information about using PowerShell and pipelines together. It's my colleague Danny.
Hey everyone, Danny Stutz. Been working in enterprise IT for about 6.5 years now. Presented at the PowerShell Summit last year. Did a talk with Frank on some, just data classification stuff. Mainly focusing on kind of the divestitures space, so doing a lot of migrations, mergers and acquisitions, building brand new environments and things like that. I see some people bringing out their phones. We have some QR codes up here if you want to connect with us on socials. Just kind of helps us, make connections outside of the conference and, just have some colleagues for the future. But with that, I'll kick it back over to Blake, kind of give him an introduction for himself.
Absolutely. So my name is Blake Cherry. I work with Danny at West Monroe. I'm a principal in our cybersecurity and enterprise technology practice. Work a lot together on divestiture and M&A type engagements, a lot of greenfield automation builds. If I catch you in the hallway, come talk to me about Purdue. I love Purdue. Or about my home lab setup, I'll talk to you for hours about home lab stuff. Same premises, Danny. Would love to connect on LinkedIn if you have a chance. And then some of the content we'll be looking at will be up on my GitHub after the talk. So as always, thank you to our sponsors. Couldn't do the event without them, certainly. So if you have a chance after the sessions, go and find the sponsors and talk to them. All great people. So today, the key learning objectives of some of the content we'll go through is to understand when and why you would use CI/CD pipelines and PowerShell in your CI/CD pipelines. We'll talk about the different pipeline deployment methods, the various approaches for running PowerShell in your pipelines, including using containers and custom Dockerfiles, and understanding the other considerations you need to take while running your pipelines. Lastly, we'll talk through some different CI/CD platform options, doing effectively a comparison of the most commonly used platforms, at least that Danny and I see when working with clients. So quick agenda, again, we'll overview PowerShell and pipelines. We'll go through some of the anatomy of a pipeline, what comprises a pipeline. We'll look at the platforms and compare them and hopefully gather some insights about the tooling offered by each. We'll then look at some practical use cases of when in your job role you might find this helpful. And we'll finish off with a nice demo that Danny and I have prepared. Before we get started, just out of curiosity, quick show of hands, who uses pipelines in their day-to-day work or who's used pipelines before? Awesome. So I think this story will definitely resonate with most of you. Tale as old as time. You created a perfect PowerShell script, seteverything.ps1, to apply some critical security configurations to servers. So this is obviously time sensitive. You're getting a lot of pressure from management. This needs to roll out ASAP. However, operationalizing this perfect script has been a nightmare. Because it's a script and you didn't have time to wrap it in a pipeline, you're executing it manually. So your team is RDPing to privileged access workstations to execute the server across an inventory that's held in Excel of server targets that need the script run against it. Approach is tedious, error prone, easy to miss one of the targets, and easy to run the script incorrectly. The work's on my machine lottery. So when you wrote this script, it was working great. You had no issues, perfect results, but your colleague is running the script, running into problems due to dependency issues on their machine. It's a nightmare. Version control chaos. No one knows what the most recent version of the script is. You and your colleague both have a version 2, but they're not the same content. Testing is effectively high-stakes gambling. So all of the patches and changes to the script immediately get their first tests in production, which is a risky gambit to be playing. Lastly, we're seeing inconsistent application of our scripts because your colleague, really messing up this rollout, keeps missing the force parameter, which is altering the outcome of the script on some of the target nodes. So I'm sure we can all empathize with this guy here. He's very upset about how this rollout has gone. Seteverything.ps1 should be the perfect silver bullet, but it hasn't been.
And what's the solution to this? Pipelines. I don't know if anyone's familiar with this XP screensaver. It brings me back memories from me as a kid. But we're not talking about these specific pipelines. We're talking about CI/CD pipelines. So CI/CD pipeline, a continuous integration and continuous delivery pipeline, is really a set of steps and a set of flow to actually deploy code in a scalable manner. You start off with your script, your code that has the definitions of what you have in it. Maybe it's a PowerShell script, maybe it's a web app, something like that. You have it in code and you have that in version control. So you have updates. People on your team are making updates to a script, maybe a certain process. It's all controlled through version control and can be deployed through the CI/CD platform. Another piece of a CI/CD pipeline is automated testing. So whenever you make a commit, maybe you make a change, you can have a pipeline that can automatically test your code or your changes to make sure they're actually working, right? It's a lot easier than having to manually test it every single time you make a change. Another piece, of what a CI/CD pipeline is there's a controlled deployment mechanism, right? So there's usually like some form of a run pipeline, run the build. Right after you've made some changes, right? You make some commits. Then you have a controlled and repeatable deployment process for maybe junior team members to actually push out code or push out things to production, right? Kind of the end result of this is consistent results. You have a consistent pipeline that doesn't change very much, right? It's going to be deploying from the same place. It's not going to be deploying from your coworker's random machine. It's just going to be deploying continuously through that pipeline, whichever platform you decide to use. So CI/CD pipelines, they can solve a lot of the challenges that we saw, in our example, with set everything.ps1, right? We can end version chaos where, there's various versions of the script out there in the wild. Maybe your teammates shared it with you on Teams and you guys are editing it in Teams and suddenly you have 12 versions, right? It ends that kind of cycle of, version control chaos. I'll kind of skip through a couple of these, but it consistently executes like we talked about, right? That's kind of one of the fundamental concepts is it consistently executes what you're trying to do for your deployment. You don't have to really gamble with prod, right? You can integrate, perhaps like a dev environment where you want to deploy the changes to. See that a lot in kind of the clients I work with is, you have dev stage prod, right? And you can target those environments and test out your changes without having to affect production environments and causing an outage for, however long. Another thing is, automatic triggers and parameters. So you can set pipelines to run, generally speaking, and depending on what platform you're working on, you can set them to run on a schedule. Or, what a lot of people will do is set these pipelines to run on an automatic basis. When you make, a commit, maybe something gets merged, it automatically runs the pipeline, which can help a lot with, streamlining the process without you having to click a bunch of buttons and run a bunch of, tests and things like that. So yeah, we're happy now. Everything's working. It's working great. You have now a pipeline to deploy your script. It's consistent. It's all under version control. Everyone understands what's going on. But something to note is, obviously pipelines aren't maybe always the right fit for depending on what you're doing, right? There's other deployment options that we have out there that we'll kind of talk through here, right? So one of these is just a typical, task cron job, scheduled task that you run on like a server or something like that. That's a fairly effective way to do it. But it's, for kind of some of those more simple tasks, maybe you're not doing, like a full-blown deployment. You're just running like maybe something that gets a computer information, every day or something like that, right? You can use a task scheduler for something like that. Cloud runbooks, so something like a AWS Lambda function or like a Azure function, right? You can have a PowerShell script that runs inside of one of those as well. And that works for some use cases, but for the use cases we're going to be talking about today, maybe not as applicable. But needless to say, with all these different options out there, there's, manual execution where you just kind of either PS remote into like another computer to run a script. That's another option. As well as like config management, like maybe like Intune or like Ansible Tower. Those are other ways to deploy some other orchestrations out if you're managing endpoints or things like that. All this to say, there's a lot of options out there for automating PowerShell deployments, but we think pipelines solve a few specific key use cases that aren't necessarily covered by these. So why, CI/CD pipelines, right? You have, code changes. You have a pipeline that can get triggered on code changes. So you're always, running whenever you're running tests or you're running updates. You have, a consistent schedule on when that runs. You can have automated tests, that are built into those. It can orchestrate that entire workflow for you. It's not like you have to go make your updates, run a test. It's, you push your change, and it can automatically kind of go through those steps of building it, testing it, and making sure it works as expected. You can also integrate, with various, source control testing, like we were talking about. You can also store secrets secretly within, a lot of these platforms. They can have, like API keys and things like that. But yeah, it's really, pipelines are made for, tightly coupled development processes. Maybe it's a, production application or a production script that you're working on that, pretty much the entire company uses. Things like that is where pipelines make a lot of sense, because there's that traceability back for version control and seeing who made these updates, how did the pipeline run, was it running successfully, and things like that. With that, I will kick it over to Blake to kind of talk about what makes up a pipeline and what are the components of it.
Thank you, Danny. So there are a lot of different CI/CD platforms out there. Again, we'll get into a couple of the different options you have here in a couple minutes, but it's important to note that the syntax of a pipeline differs slightly between these different platforms. So I've tried here to break down, generally speaking, the anatomy of a pipeline with these core kind of concepts being applicable across the different platforms. So before we dive in there, I'll also note that there are some platforms that allow you to build pipelines and workflows and processes through a user interface, but the industry trend and the direction we're seeing is moving to defining pipelines as code. And there are certainly advantages of that. Your code's version controlled along with your application code or your script code. It's easier to typically maintain versus going through a user interface. But again, wanted to state that is certainly an option. But the common components of a pipeline, things that you need to consider as you actually write the file, are first the triggers. So what is kicking off the pipeline? As Danny mentioned, depending on the platform, you have different options of what that trigger could be. Maybe it's a schedule, like a scheduled task would run off, but most commonly we see these triggers being code commits or pull requests, things that are event-based in your repository. Outside of triggers, variables are important. So ways to store important configuration settings or to pass in certain values. As Danny noted in our example, in the pipeline scenario, we're able to much more cleanly audit and ensure the consistency of the variables that are passed into our scripts that are run through the pipeline. We then have different divisions of where the code lives in the pipeline file. So you have stages, jobs, and then ultimately either steps or tasks. The stages are major divisions of work, so you might call a stage your build stage, and you might have a deployment stage. The stages are then subdivided into jobs, which can be run in parallel within a stage. So depending on what the stage is, you might have a job running to compile the code and another one to build some of the prerequisite infrastructure, but those can, again, run in parallel within a stage. And then ultimately, underneath a job, you have individual steps or tasks. So this is where your code is defined or where the actual instructions live within your pipeline. But where does the magic actually happen? Where is your code actually running with these mysterious pipelines? Pipeline agents are the machines that ultimately execute your CI/CD jobs, and mainly there are two options of where that agent can be hosted. It can either be hosted in the cloud through typically a managed type of relationship where you have the cloud provider spinning up a virtual machine for your pipeline to execute and then destroying that as that job finishes. Or alternatively, you can choose to run the code locally on an agent machine that you host yourself. This execution context is a very important consideration as you author and build your pipelines for a few reasons. With a self-hosted agent, there are obviously ancillary tasks involved with spinning up the host. You've got to build the infrastructure. You've then got to patch it. You've got to maintain it. You've got to configure dependencies manually on that host. And you have to consider the impact of running a pipeline over and over again on that same host. With a cloud ephemeral managed option, there are, again, advantages. You have predefined software installed on the image that the cloud provider will deploy for you. Typically, this is documented pretty thoroughly, at least for the platforms we'll be talking about today. So it's much simpler to set up, typically faster, but oftentimes you're limited in your administrative ability to install certain things on that VM, and you have no inherent access or line of sight to your local networks. So the traffic, unless you configure it differently, will be over the public internet as it goes and reaches out to the nodes that your scripts are contacting. Typically, my approach with selecting a build agent is to first determine the security and compliance needs of where a client might need their scripts run, considering the line of sight. Again, if we have to run a script against a domain controller, that needs to live with network site to that domain controller. And if those are hard requirements, we'll go self-hosted. Otherwise, typically it's easier to use the ephemeral managed host. Now you can also use containers as an execution environment for your pipeline code. So there are several advantages to doing this. First and foremost, you guarantee that consistency of your execution environment. So every time you run your pipeline, you know exactly what that environment looks like, you know what dependencies are installed, and you're confident that it's going to work as compared to running on a virtual machine. Dependency bundling, again, you can make sure all of your dependency packages are defined in code, typically through a Dockerfile, which we'll talk about here in a moment. Making sure all of the necessary dependencies are available for you when running your scripts. And then lastly, isolation. So it's helpful to run in a container environment to avoid conflicts with other software on the agent or versioning concerns that could also come up in the same context. So again, Dockerfile is a helpful tool for defining exactly what that execution environment looks like. You can customize which base operating system you're using, the required tools, libraries, configurations, et cetera, that are available in that execution environment. So a good example scenario that I've pulled from something that I've been doing recently is I needed, when I was running a pipeline, Ansible and specific Python libraries installed on my agent. Those were not pre-installed on the cloud ephemeral host that I was using. And so instead of installing those dependencies every time at runtime, which took forever, I was able to use a Dockerfile to define an image and consistently use that as my execution environment. Now, PowerShell is a great fit for running in pipelines for a few reasons. First and foremost, with PowerShell 7, it's cross-platform. So you can author one pipeline and run that same pipeline across Windows build agents, Linux agents, and even Mac agents. It also makes a great glue amongst your other automations in that you can use PowerShell with its native OS and file system capabilities, its .NET integrations, and excellent REST API interactions to orchestrate other tooling. So that might be as simple as calling AZCLI in PowerShell, or you can go as deep as, again, API interactions using PowerShell to bring it all together in your pipeline. PowerShell also obviously extensible with expansive module support, so a lot of capabilities there that are quick to pull off the shelf. And typically teams have pretty good familiarity with PowerShell, so you can avoid siloing your pipeline development to single groups in your organization, and you can empower teams, your systems administrators, your developers, and even your DevOps engineers to all contribute when building pipelines. Next here, we have a couple key security considerations that you should definitely take as you go to author your pipelines. So first, it's important to remember when authoring your pipeline what identity context your code is going to run under. So that'll differ depending on the use case and on the context of where it's being run, so either on a self-hosted agent or on a managed one. But it's important to consider because it'll influence or dictate how that's ultimately run. Also, obviously, we never want to hard code credentials. So all of the platforms we'll talk about today have clean integrations, as Danny mentioned before, with secrets management platforms and service connections for establishing connections to cloud platforms. So certainly want to either put those API keys and passwords in a vault or use whatever the platform provides as its secrets container method. Lastly, again, a pretty generally applicable point here, but make sure when you build your service connections to your cloud environment or to your on-premise environment to apply least privilege. Multiple people could be triggering this pipeline or could have the capability to commit code to it, so we don't want that service connection, to use Azure terminology, as a global administrator.
Yeah, One thing to note too is on like the cloud credentials, like most of the platforms when you talk about like Azure DevOps and like GitLab do have, a form of like a secret store, but like it's typically recommended to use a different type of a secret store, like AWS like Secrets Manager or an Azure Key Vault, just because that way you're in control of those secrets. Whereas, if it's in GitLab or in Azure DevOps, there is a potential it could be exposed. So it's just typically better to use some form of an actual key vault to kind of facilitate that.
Absolutely. So we've accomplished all our goals. Our script's looking good. We've completed our checklist. So next we'll talk through some of the different platforms. Again, there are numerous CI/CD platforms. So this is a trimmed down list, certainly not exhaustive. But these are the typical platforms we see in enterprise client environments. So starting at the top here, we have Azure DevOps. Azure DevOps being Microsoft's CI/CD platform. The key value proposition and what I've seen with DevOps is its close integrations with Azure. So if you are an organization that has an existing Azure footprint, or if you're a .NET shop, a lot of .NET code in your environment, it could be a great fit for you to quickly adopt and bring into your organization. For running PowerShell, Azure DevOps makes it super easy. There's built-in PowerShell on the ephemeral agents that we discussed just a moment ago. So when you pull those cloud-managed hosts off the shelf to run your code, you already have PowerShell installed, along with some Azure PowerShell modules. And there's also in Azure DevOps a task marketplace, which is effectively a store that contains predefined steps or effectively scripts or actions that your pipeline can take. The next platform we'll take a look at today is GitHub Actions. So GitHub Actions is the pipeline apparatus that sits atop GitHub. Similar to Azure DevOps with Azure, the GitHub Actions pipelines are super integrated with your GitHub repository. So if your code is already in GitHub, it probably makes sense to investigate using GitHub Actions to run your code. Similar to Azure DevOps as well, the managed agents that you would pull off the shelf to run your GitHub Actions pipelines on, those come pre-installed with PowerShell typically. So that's already available for you to use. Super easy and simple to put together in a pipeline. The next platform on our list is Jenkins. Jenkins looks different than the other two in that it's open source and typically self-hosted. Jenkins is really a great fit in environments that either have strict security and compliance concerns, so they need to self-host their CI/CD platform, or if you need to orchestrate large, complex, or legacy workflows. So with the extensibility, it being an open source platform, there's a lot that you can do with Jenkins if you have the teams that can support and build those integrations. With Jenkins, as it is self-hosted, typically you would self-host your agents, so where you're running your code. So it's important to make sure PowerShell is installed on that agent if your pipelines will run PowerShell code. Lastly, we'll take a look at GitLab today. GitLab looks very similar to Azure DevOps in that it's an all-in-one CI/CD platform. And I really see the value proposition in GitLab being a distinct platform from sort of the Microsoft umbrella that has strong tool integrations, very strong integrations with containerization and with Kubernetes. And if you're looking for a unified DevOps platform for your team, again, that's outside of Microsoft's shop and tooling. When deploying pipelines through GitLab, typically you would use container images. And with the official PowerShell image, it's simple to pull a PowerShell supported Docker image off the shelf and run your scripts there. So it doesn't look too different than Azure DevOps and GitHub Actions. So again, each pipeline's syntax does differ. So in the next few slides, I'll have a few examples of what the same task looks like on all of these different platforms and all these different pipelines. So just picked a very simple example use case here. What we'll be doing is reading a version.txt text file from our code repository, so where our application code lives. We'll append the pipeline's build ID, so an ID generated at every run of the pipeline. And then we'll print that updated file to the pipeline output. So in Azure DevOps here, we have a YAML-defined pipeline file, simply called Azure pipelines.yaml. You'll see a couple familiar concepts in the YAML definitions, starting with the trigger. So we've specified here that this pipeline should be run every time there's a commit to the main branch, which is what would enact the pipeline. We're then specifying where this pipeline should be run. So in this context, we're running it using the ephemeral managed latest Windows image that Microsoft would offer us. And then we define the different steps that our pipeline will run. In this case, just a simple inline PowerShell script.
I was going to mention too, so like if you look at this like script block too, right? Like you can clearly see that's just like the definition of like the PowerShell script in there, but you can also, switch it where you can have like a script within like that same folder, wherever your app code is, and just point it towards it. So if you have like a .ps1 file, it's huge, right? You don't want that in your YAML and formatting it and everything is going to be kind of horrible. So, it's typically easier if you just point it towards like a .ps1 file, which is definitely a possibility, at least within Azure DevOps. So, yeah.
Absolutely. And I would definitely recommend that approach if we didn't need to fit all of the content into one screenshot here.
The screenshot purposes.
So next, quickly looking at a GitHub Actions pipeline here. Again, very similar to the Azure DevOps pipeline, but syntactically slightly different. You'll see the same concepts of the trigger at the top on push. You'll see the jobs defined, the runs on, which would be analogous to the pool that we saw in the previous example, and then again, the inline PowerShell code defined in the pipeline. Now, looking at Jenkins, again, it being kind of the different platform of the four we're looking at today, Jenkins actually uses a different syntax than YAML, so it uses the Groovy syntax to define the pipelines, so you'll notice it looks a little different. But the fundamentals and the key structural pieces are still the same. So we have the agent that we're defining, where's their code going to run. We then define our stages, and then the PowerShell code inline that'll run when the pipeline's executed.
Leroy.
Had to put that in there. Last here, we have a snippet of a pipeline from GitLab. Once again, same fundamental structural elements, the stages that we've defined, as well as the build agent. So we can see in this case, we're using a specific image that is Microsoft's official PowerShell container image. And then we define inline the scripts in its entirety to be run there. Again, to Danny's comment, highly recommend version controlling your script files that are run, but in this example, we've defined them inline. And I'll pass it back to Mr. Stutz.
Yeah, thank you. So we'll kind of go quickly through some, practical examples, some situations that you might have run into at your workplace on where you could use a CI/CD pipeline. So we'll start with kind of a, systems administrator perspective. Maybe you have some server configuration with DSC v3. You want to keep that, version controlled so you have a consistent, image and consistent configuration across, all of your servers that are maybe deployed in Azure, whatever cloud platform you have, right? Then we have, maybe a developer, right? So if you're, a developer who's, developing some Python web app, or you have, some Python specific library, being able to have a pipeline that automatically, builds, tests, installs all the dependencies on the pipeline is a huge benefit of CI/CD pipelines, especially as, an app dev, right? You want to have those things installed automatically so you don't have to worry about that, and there's no more problem of, oh yeah, it runs on my machine, right? It makes it very consistent for anyone who runs a pipeline. And then there's also the DevOps engineer perspective. So if you're deploying infrastructure as code, or if you have you're using like Terraform, or maybe you're building some of your infrastructure using PowerShell, so another great use case for CI/CD pipelines and where you might see it out in the wild. And then also, a SecOps engineer, right? There's a lot of different, personas and people who can use CI/CD pipelines. SecOps being one of them, right? You can include like what I've seen a lot at like previous companies is like a security pipeline that's built as basically like a step of the whole workflow, right? You have basically your build phase, you're building all the files, and then you have, maybe like some tests that you run, and then also, maybe some security scans that maybe identifies a high vulnerability, something like that. You can catch that all in the pipeline, and so you're making sure that, the code is scalable, it's secure, it passes all the tests, right? And that's kind of the value of using CI/CD pipelines, especially with PowerShell. So we'll kind of go through, some quick examples here, Python build and deployment pipeline. So we'll be demoing this one specifically. We have a pretty kind of, pre-built pipeline already to kind of show, the flow, how we have it set up, all the code for that. So we'll go through that, once we're through here. But kind of, yeah, the key, value proposition is really what we've been always talking about, which is you have a repeatable process that's consistent inside of a pipeline. You have it version controlled so that everyone's on the same page on what version's being used and what updates have been made. And it automatically, runs any of your code through, an automated tests, maybe using like Pester or something. But it, kind of puts that all together in a single flow to make it easier to kind of work on. So another example using like infrastructure as code deployment. So if you're, a DevOps engineer, you can use GitHub, GitHub Actions to deploy a specific resource to, Azure. Me and Blake are more Terraform guys when it comes to infrastructure as code, but we'll use this as an example. But it's another kind of way you could use, perhaps GitHub Actions. You could use it in Azure DevOps as well, right? But it's just kind of different use cases for each of them. Server configuration with DSC. So that's another, if you're a systems administrator, you want to make sure all your servers have the same configuration. Keeping it in the pipeline, make sure that configuration is, maintained. You can have, people who approve, changes to that configuration. Maybe that's like a security manager or something like that. So it makes it easier for just making sure your, standards are defined. It's being reviewed by the right people. And it's all, in one central place without having to scramble to find disparate scripts everywhere on the while. And then kind of lastly here is around, security compliance checks in a pipeline. So you can have, automatic security checks against maybe like a Windows server or maybe even code. I've seen that a lot with, specifically like Python code and like C# code is having vulnerability scans at the end, kind of the tail end of a build phase. That can help you, a security ops engineer to understand, what vulnerabilities are out there. Is this okay to move to production? Usually you would have this in like a dev or a stage, kind of environment so you can, test and make sure it works before you move it into prod. But this is just kind of another good use case for, pipeline, especially in GitLab, it works pretty well as well. So with that, I think we can get over to the demo here.
Awesome.
Yeah.
So, yep, as Danny mentioned, we have a demo prepared that's mostly aligned to the first use case. So taking a Python web app and building it and then deploying it to Azure using an app service plan and an app service. We do integrate some of the other fundamentals of the other examples in that we're building some of the infrastructure as code in our pipeline to make sure that we're in a stage where we can deploy our code. And we also manage, I think, some PowerShell in there to paste some build info. So we'll show kind of how PowerShell can be that glue to bring the stages together to move you from the build to the deployment. So let's see here.
Is everything okay with that system administrator? He's the only one.
Yeah. Is any systems administrator really that happy? And absolutely feel free to ask any questions. We'll be just looking through kind of the whole structure here, kicking off the pipeline. So if anyone has any questions, we're happy to help answer. So starting at the top again, this is hosted in Azure DevOps. So we have my personal DevOps organization here, nicely named my first and last name. DevOps organizations can be thought of as effectively your tenant. It's the overarching umbrella resource that contains all of your projects, of which I have one, pipeline demo. And within this Azure DevOps project, you'll notice a few key items here on the left. So we have our repositories, so where our code is stored. In this case, you can see our pipeline file, nicely version controlled, along with the code for our Python Flask app defined here.
Boo, Python.
And then lastly, importantly, we do have our pipelines. So the pipeline that's defined here is the same pipeline as is defined in code. The process to create the pipeline in DevOps is effectively selecting that YAML code file and stating that that's a pipeline. So what we'll do here is we'll go ahead and kick off this pipeline. It takes about 7 minutes and 56 seconds to run. You can see it took us a few tries here. So as we go to select the pipeline and run it, you'll notice here that it allows us to select some variables. So if we have any input variables to add at the point of runtime, we can certainly do so. We can also pull secrets in and other values from vaults. We can also select which stages of the pipeline we want to run. So again, going back to the anatomy of a pipeline, stages being that kind of top level entity. Maybe we only want to run the build or the deployment. We could certainly do so here. And so we'll go ahead and click run. And our pipeline will start working. So first, it's going to pull one of the ephemeral managed agents off the shelf. So it's going to grab that VM image, spin up a virtual machine for the purposes of executing our pipeline for us. What's nice about Azure DevOps is if you have a public repository or a public project, you have an unlimited amount of cloud-hosted agent runtime, so you can run as many of these as you'd like. And you'll see that it completed the build job very quickly. It made sure the dependencies were installed. It created our build info file. So we grabbed from the pipeline variables a couple of the key pieces of information pertaining to this build, and we saved that as a file.
Yeah, that was our PowerShell piece, was the creating the build info file. So we have a couple pieces that are specifically PowerShell in this, and there's the step of provisioning Azure resources. So that's our PowerShell step of like actually deploying the infrastructure we need, which is just an app service plan and an app service. And then, yeah, the build info from the file, that was kind of like our main demonstration, was just like you can basically run a very simple like PowerShell script that just gets like the build information on like what's the pipeline build number. And you can obviously, modify this to your needs, but that was kind of our specific demo.
Absolutely. Again, this is an example. Something more common that I do day to day when working with clients is using PowerShell to perform file system operations. So maybe I need to move a directory from one of my other repositories and bring that into my final script package before I publish that. PowerShell is a great tool for doing that. So this is going to continue to run. Right now it's deploying some Azure infrastructure. It's deploying a new app service plan and the app service itself to host this Python web app. So we'll let it work on that. And while it does that, let's take a quick look at the pipeline itself. So here's that pipeline file. Again, same fundamental aspects. We have our variables defined, we have our stages defined. In this case, the first stage is again build. So going back to that PowerShell example piece, after we install our dependencies, we're creating the build info file. Notably, you'll see the syntax used here for pulling in some of these parameter values. These are exposed by the pipeline and can be used in your script. So we're pulling information about the pipeline itself, referencing it within our PowerShell script, and then using our PowerShell script to publish that information as a file as it finishes this step. One thing that we didn't really have an opportunity to dive too deeply into in some of our formal content, but certainly is important, is the concept of an artifact or a build artifact. The context is not persisted between stages. So if I write a file and output it in this step here, that is not inherently available to me in my subsequent stages as I go to provision my infrastructure or deploy my code. So what we've done here is published that file as an artifact. What that allows us to do is then to pull that artifact back down in subsequent stages and use that as we need. So you'll see again that we've published that file. We then provision our infrastructure. As Danny and I have also mentioned, and makes us cringe, we've done this in PowerShell. We would typically do this with another tool like Bicep or Terraform. But for example's sake, we've used PowerShell. So it's creating our Azure resource group, then our app service plan, and then our AZ web app, all the necessary infrastructure pieces and components to run our web app. And then lastly, we have our deployment stage. So you'll notice that this stage explicitly depends on the build and the provision phase. If this could run in parallel, we could configure it to do so, but obviously in this case, we have to have the code built before we can actually deploy the application. One last thing to call out here, the task at the bottom, you'll notice, is the Azure Web App version 1 task. Again, Azure DevOps offers a marketplace of different pre-created tasks that you can quickly pull off the shelf and use to do things like publish code to a web app. And we'll switch back to the pipeline. So it looks like it's finished deploying its infrastructure, it's finished with the build, And so now it's working to deploy that web application to Azure.
Yeah, it's going to take a while.
Yeah, might take a while. While this runs, we'll keep an eye on it. We'll pop quickly over to Azure to take a look at some of the infrastructure. So Danny and I did deploy one of these instances in advance, as it does take a bit. We'll see here the resource group that we created, as well as those two infrastructure components, the app service plan and the app service.
As well as the build number.
Good call. The build number is appended to the web app there to make it unique.
Yeah.
And then you'll see our web app here. So
Very simple.
we've taken that file that we published using PowerShell, that we created with PowerShell. We published it as an artifact, so it was available subsequently in the following stages in our pipeline. We then, in our Python code, if you want to take it from here, Mr. Python expert.
Yeah, and basically we just pass it in through here. Where is it? Where's VS Code? And I'll switch back here.
Yeah, I think it's like, yeah, that, maybe
Pipelines,
top tab.
YAML, top tab.
I'll just go to the repos.
Yeah, go to YAML. So yeah, basically we're just passing in, like if we just go to app.py, it's a very, very simple like
Very
Python code. But basically, yeah, we're just passing in this build info, which is, it's right up here. It's basically looking for the build info.txt. So we had a PowerShell script that basically created this build info.txt, and then the app is literally just going, finding that, because it has it as an artifact from that pipeline, right? Like you have an output from it, and it basically just passes it in and sees, okay, what is the actual build info, right? It's a very simple web app. Obviously, Python web apps get very complicated, but just kind of wanted to demonstrate like how you can basically pass in like a text file through it. Yeah, question?
So I'm not super familiar with the concept of an artifact, and I'm just curious, when it builds that file, is that a file that is then being committed back to the repo, or is that in existence for the duration of the pipeline and then it's gone afterwards?
Yeah, so your question is basically, for like an artifact, is that like kind of short-lived or is that like long-term lived, right? Is that kind of your question?
Yeah, so in this context, we're defining the artifact for just the duration of the pipeline, and then it's actually published to the pipeline's run execution itself. So if we go back into the last one we ran a couple of minutes ago, you'll see that that artifact was published as a pipeline file. So this zip file is hosted on the DevOps platform, so to say. But you could, if you did need to commit code back, certainly facilitate that. Or you could publish these artifacts to a storage account or an S3 bucket and use that as sort of your artifact drop location. Again, these build agents are ephemeral in the way that we're running these. So that VM is only going to live for the duration of the pipeline's execution. So it'll be lost as that VM is deprovisioned, which is why we need to use the artifacts here.
Thank you.
Sure. Quickly check our pipeline, see how it's coming. Looks like it's still thinking. It's getting there. Any other questions as we wait on the pipeline here a moment?
Okay, yeah, sorry. So the question was, how do you parameterize like the different environments like dev, stage, and prod? So typically, like the way I would do it at least is like through, if I go back to the YAML, there's usually like, you can basically target like specific branches, right? Like if you have like a dev, stage, and prod, right? It's like your prod will be called like main, your stage will be maybe called like release is what I've seen, and then dev can be like a feature branch. So if we go back to the actual pipeline code, where are we at?
Jump to repos from there.
Oh yeah, let's go here. Repos, files, ADO. So you can see like the triggers based off of like main, right? So you can specify multiple triggers for like the pipeline. So you can do like dash release, and then you could do like dash, like feature / star, and that can be for like your developers who have like feature branches based off of release. And so then you can target basically those specific environments, and then also you can use like environment specific like variables. What I've done is like in the past is like had like a environment variables file inside of like Azure DevOps or like GitLab that are for like dev, stage, and prod. And they can pass in like that environment variable through like a a parameter that's stored there. So it's like you can call, if you're deploying to like main, you'd have a series of steps. One is for like deploying to like development or deploy to stage, and those could target maybe the specific branches. So you can set the trigger on like stage, call this staging like environment file that has like all the environment variable information in it, so that you can target whichever branch you want.
Yeah, and one more sort of lens or aspect of the different environments has to do with how you're actually authenticating to the target environment. And so the way that that's done, best practice-wise in Azure DevOps, is through what's called a service connection. So you'll see that I've created one here to my personal Azure tenant. And for testing purposes, this is certainly not best practice, but this is an owner of my management group, so it kind of has permission to do everything in all of my subscriptions. But best practice would certainly be to define individual service connections per environment, only giving it access to dev or prod appropriately. These are super easy to create. They effectively create application registrations in your tenant, and you can scope those appropriately. And then in the pipeline, you'll notice in the task here that we're using to actually deploy the app in some of the infrastructure, we just simply specify which service connection we want to use. So to Danny's point about having an environment variables file that looks different from each tier, you could specify the different name of the different service connection you want it to actually use as it deploys things from your repository.
Yeah, usually you'd have like, I mean, at least like in AWS, it's like I've seen where it's like you have like 3 separate accounts basically. In Azure, you could have like 3 different subscriptions. You'd set those all up as like independent like service connections, and then basically just switch, like depending on what branch it is, you could switch that to like, oh yeah, use this service connection if you're connecting to Stage, right? And it makes it really kind of easy to do that. It's super easy, yeah, and then you can kind of get like a template down for like the rest of your environment depending on how big it is, and you kind of just reuse that. Yeah, of course. Any other questions or anything?
Yeah, I think, do we maybe have one more other question? No? One more sort of piece here, again, talking about variable inputs and the different environments, is you do, again, have the option when you run your pipeline to specify defined variables. So there might be something that needs to be defined by whoever's executing the pipeline at runtime. You can surface those almost in a user interface structure here and have those be defined. So maybe that's a name or a tag value or something to that extent. It's super easy to specify and add here. It does look like our pipeline succeeded, which is great news.
Woo! We did it.
And so if we jump back to the Azure subscription, we should see if I grab this one a second.
Refresh. We got
Yep.
resource groups, so we got our new resource group.
Number 72.
72, so we got the build. That's one of the parts of this app is just we just append the build number to the end of it. It's not anything fancy, just kind of wanted to show how you can use like PowerShell inside of a pipeline to kind of parameterize things, or maybe you want to switch based on a build number, maybe you're doing some development or something like that. It's easy to pass those outputs from a pipeline into whatever you're deploying, right, through the pipeline. It helps a lot. So let's see, does this work? Not yet. I'll blame DNS.
I'm still thinking.
It's always DNS, no matter what. Even if you don't think it is, it's always DNS. But yeah, we showed the quick example of kind of like what it looks like in the end result. But this is just like a really nice way to be able to control your deployments and have a version behind it, but also just with all the development and testing, it's easy to kind of like test like a website or deploy like updated application code, right? That's the main benefit of CI/CD pipelines. It allows your team to move a lot faster than they normally would if they're just working in kind of their own little box and bubble, right? You can all kind of work together, where, how fast you're going, what, things you're doing, right? You're well aware of that. And that's really one of the main advantages of using CI/CD and just Git in general.
Awesome. Well, thank you for watching our example. Happy to continue to answer questions on anything pertaining to pipelines or to the PowerShell and pipeline together usage. But in conclusion, hope everyone was able to glean something from this presentation on any of these learning objectives, but really appreciate everyone's time this afternoon.
Everyone.